Good day, my dear students, and welcome back to our science class. And for today's video, I'll be discussing molecular and empirical formula. For objectives is for you to able to know the difference between molecular and empirical formula by its definition, calculate the molecular empirical formula, and know its importance of molecular and empirical formula in chemistry. To begin with, when you say empirical formula, it is a formula which has been reduced to the lowest terms. And when you say molecular formula, it's a formula of a compound in which the subscripts give the actual number of each element in the formula. Now, if you're going to observe this, they are identical. Okay? And the second here is when you scale up from the empirical formula to the molecular formula, they are most likely by a whole number of factors. So as you can see here, we have the H2O or the water for the molecular, which is identical again in the empirical formula. For the C2H4O2, when you say empirical formula, it was being simplified to a CH2O. Then in the CH2O, we have again identical, and for the C6H12O6, still in the empirical formula was being simplified. Now, to find the empirical formula, first, if there's a given percentage of each element, so assume it's 100, okay, 100 percentage, by 100%. So just simply convert it to grams, so from 100% to 100 grams. Now, after that, convert to mole by dividing the amount in grams by atomic mass of that element. So if you're going to recall your previous topic in chemistry, you need to look for the atomic mass unit of a certain element, which we get it as the mass, and at the same time the unit will be grams per mole. So you're going to divide it to cancel out the grams. Now you're going to simply select the smallest value and divide all values by this smallest one. Now, if the result of step 3 will either be very close to a whole number or will be recognizable mixed number fractions, if any result from step 3 is a decimal mixed number, you must multiply all values by some number to make it a whole number. So this will vary. For example, you got 1.33. Since it is a mixed number, you have to multiply it by 3. If you have 2.25, you have to multiply it by 4. If you have 2.5, you have to multiply it by 2, so on and so forth. So definitely, these decimal numbers, if you convert into fractions, there you will able to identify which number or what number you're going to use for able to multiply it and make it as a whole number. To summarize this as your guide, first, again, percent to mass. So you need to convert all the percentage into mass. For example, you have 100%, convert into a 100 grams. Followed by mass to mole. Since you have converted the percentage into a mass, you need to find the atomic mass unit of a certain element. Then, you're going to divide it for you to be able to get the mole. Now, as you divide it, you will analyze all the numbers and look for the smallest value, and as you get the smallest value, you divide it, then multiply till whole. Ibig sabihin, kapag nakita natin that the decimal is still in mixed fraction, we have to multiply it. Depends on what will be the result of our answer. Okay, let us try this example number 1. Find the empirical formula of a compound which contains 54.93% potassium, 38.73% boron, and 6.34% hydrogen. So the first things first we're going to do is you need to write all the given. So label lang natin. Lagyan natin dyan K, that is our symbol for potassium, which has a 54.93%. Next, we have boron, that is 38.73%. And then we have hydrogen, that is 6.34%. Now, next is we have to convert it into grams. So definitely, you write 54.93 grams. Next, 38.73 grams. And then lastly, 6.34 grams. Okay? Now, you're able to convert it into grams. Now, we'll be looking now for the atomic mass unit of each element kasi i-divide naman natin siya. Okay? So, we have here the potassium that is 39.098. So, let's divide it by 39. A round off na yan. Next, for boron, we have 10.81. We divide it by 11. Okay, grams per mole. And then for hydrogen, that is 1.008. We divide it again, so that will be 1.001. Okay, so let's now start dividing this equation. So calculate tayo. So you got 54.93 divided by 39, you got 1.41. moles. Okay, next, 38.73 divided by 11, that will be 3.5 mole. Next, 6.34 divided by 1.001, and you got 6.3 mole. Now you're able to get all the answers as you divide them. Now the next will be, we're going to divide it by the smallest value. So, again, label lang natin ulit yung elements natin because the target here is we're getting the ratio. So, we got potassium, boron, and then hydrogen. So, there, we got 1.41 mole, 3.5 mole, and 6.3. So, the smallest value that we got here is a 1.41. So, again, we can just simply divide. So 1.41 divided by 1.41, 3.5 divided by 1.41, and then 6.3 divided by 1.41. So let's calculate this. So 1.41 divided by 1.41, that will be 1. Next, 3.5 divided by 1.41, that will be 2.5. Next, 6.3 divided by 1.41 divided by 1.41. There you got 4.47, or let's say 4.5. Okay. Since we encountered here a mixed fraction, so what we're going to do here is we're going to multiply it by 2. Okay? So 1 times 2, and then 2.5 times 2 and 4.5 times 2. So 1 times 2, that will be 2. 2.5 times 2, that will be 5. And then 4.5 times 2, that will be 9. So the empirical formula of this problem will be potassium 2, boron 5, hydrogen 9. And there, this will be the empirical formula for this example number 1. Okay, so let us try this again for example number 2. Find the empirical formula for a compound which contains 26.8% of tin, 16.0% of chlorine, and 57.2% of iodine. So again, we'll just simply write first all the given. So meron tayo ditong tin, we have chlorine, and we have the iodine. So tin, we got 26.8%. For chlorine, we got 16%. And then for iodine, we got 57.2%. We'll convert it to grams. So that will be 26.8 grams. And then we got 16 grams. And then we got 57.2 grams. We'll be looking here at the periodic table, those elements, and check their atomic mass unit. So first we got tin. So this is our tin. We got 118.7, or let's say that will be 119. So you write here for tin, so 26.8 grams divided by 119 grams per mole. For chlorine, that will be 35.45, or let's say 16 divided by 35 grams per mole. Then for iodine, we got here 126.9. So we can use 127. So 57.2 divided by 127 grams per mole. So now we're going to divide it with the use of this calculator. We'll be now calculating. So again, 26.8 divided by 119. So we got 0.22. Next, 16 divided by 35. So we got 0.46. Next, for iodine, 57.2 divided by 127. And there we got 0.45. Since we got no mixed fraction here, so just simply look on the lowest value. So we got 0.22, right? So we write here again. 14, we got 0.22 divided by 0.22. For chlorine, we write 0.46 divided by 0.22. And then for iodine, we write 0.45 divided by 0.22. So let us now calculate all of them. So 0.22 divided by 0.22, that will be 1. For chlorine, 0.46 divided by 0.22, we got 2. And then for iodine, 0.45 divided by 0.22, we got also 2. And there, we got already the empirical formula. So write EF, or empirical formula, for the shortcut. So since our tin is 1, so you just simply write tin. And then for chlorine, you write 2. And then for iodine, you write also 2. So there, we got already the empirical formula for this example number 2. Now for the molecular formulas, it says here that it's either the same as its experimentally determined empirical formula, or it's some whole number multiple of it. So to determine the molecular formula, you must know the compound's empirical formula and molar mass of the molecular compound. So the steps here: first, you must calculate the mass of the empirical formula, which you have already found or it will be given to you. Next, divide the known molar mass by the mass of the empirical formula, and then you will multiply the number by the subscript of the empirical formula to get the subscript for the molecular formula. So let us try the example. The molar mass of compound is 181.50 grams per mole, and the empirical formula is C2HCl. What is the molecular formula? Now, for us to be able to get the molecular formula, so first we get the molecular mass of the given compound. So we have here the C2HCl. So by getting the molar mass, so we're going to label it and get its atomic mass unit, each element. So for carbon, we got 12, and then we're going to multiply by its subscript 2. So we got here 24. And then for hydrogen, we got 1.01 multiplied to 1. Since the subscript of hydrogen is 1, therefore we got 1.01. And then for chlorine, that is 35. So 35, we multiply it by 1 because chlorine has a 1 subscript or 1 atom. Definitely we got 35. So all of this will be added. 24 plus 1.01 plus 35, we got 60.01. So since we got already the molar mass of our given compound, next we're going to do is we're going to divide to the given molar mass of the compound. So we got here 181.5 divided by 60.01. So the answer here is 3. So the next thing you're going to do is this 3 will be multiplied to the subscript of the given compound. So we have here carbon 2, hydrogen, and then chlorine. So since that hydrogen and chlorine has a subscript of 1, indivisible 1, we're going to multiply this 3. Okay? So 2 times 3, 1 times 3, and then 1 times 3. So the new molecular formula here will be C6H3 chlorine 3. So this will be our molecular formula. So let us try this again. Find the empirical formula for a compound containing only carbon and hydrogen if it is known to contain 84.21% carbon, and if the molar mass is 114 grams per mole. What is the molecular formula of this compound? So in this problem, the first thing that we need to do is to find the empirical formula. So it says here that carbon has a 84.21% of carbon. Now, since hydrogen has no percentage, so we can assume that the hydrogen has a 100%, and we're going to subtract it to 84.21% of carbon. Since it says here that if it's known to contain 84.21%. So here we're going to calculate. So 100 minus 84.21, that will be 15.79%. So the next thing that we're going to do here is we're going to get the atomic mass unit of each element. So for carbon, we got 84.21 will be divided on the atomic mass unit of carbon, which is 12. For hydrogen, we got 15.79 grams divided by 1.01. So let's compute. (84.21) divided by 12, we got 7, and then 15.79 divided by 1.01, we got 15.6. So now we're going to analyze again our solution here. So we'll be looking for the lowest value. Since we got 7 here, so we write here carbon, so 7 divided by 7, and then hydrogen will be 15.6 divided by 7. So for carbon we got already 1, and then for hydrogen will be 2.23. So since we have here a mixed fraction, we were going to multiply it by 4. So carbon 1 multiplied to 4, and then hydrogen 2.23 multiplied by 4. So 1 times 4, we got 4, and then 2.23 times 4. So let's compute here. 2.23 times 4, we got 8.92 or 9. So we just round it off. So the empirical formula here will be carbon 4 and hydrogen 9. So this will be now our empirical formula. Now, next will be if the molar mass is 114 grams per mole, what is the molecular formula of the compound? So with the use of this empirical formula, we'll be looking the empirical formula mass. So again, we're just simply getting the mass of carbon 4 and hydrogen 9. So just simply write here, and then we get its empirical formula mass. So carbon, the mass of carbon is 12. We multiply by its subscript of 4. And then for hydrogen, we got 1.01, and then we multiply it by 9. So there, let's calculate. 12 times 4, we got 48. And then 1.01 multiplied to 9, we got 9.09. So we'll just simply add this. 9.09 plus 48, that will be 57.09. So this will be now our empirical formula mass, or the EFM. So there, we'll be using this EFM to divide here on the molar mass. So the molar mass 114 divided by to its empirical formula mass, which is 57.09. So there we calculate 114 or 114 divided by 57.09. So we got here 2. So we just simply rounded it off. So with that, we write again the empirical formula, which is C4H9, and then we're going to multiply to its subscript. So C4 multiplied 2, and then hydrogen 9 multiply it by 2. So for our molecular formula will be carbon 8 and then hydrogen 18. So this will be now our molecular formula. So the importance of this empirical formula and molecular formula is chemists use it for a compound has been analyzed for percent composition. So the formula can be calculated, the empirical formula. Now, if the actual weight of a single molecule is known, then the molecular formula can be calculated as well. So again, it may seem that they're identical, but when you're going to compute it, they'll always be different, and at the same time, in the empirical formula, they're always being simplified. And with that, this is the end of this session. Thank you and see you on the next video.